I'm going to explain how an inverting amplifier works. So what an inverting amplifier does is it takes a input voltage that's fed into the inverting input of the amplifier and then outputs a voltage but with a given gain and inverts the sign. Now, right now, what we know about the amplifier is it's just this triangle, and there's some stuff in it, but we're not really worried about it. We know it has two inputs and an output. The two inputs are the inverting input and the non-inverting input. Now for the inverting amplifier, the inverting input is the one that gets a voltage, and the non-inverting input is the one that's grounded. Now the way that we're going to find the gain of this inverting amplifier, which is really the purpose of this video, is by using some simple circuit analysis rules and taking into the fact that there's going to be a current that runs here and using those rules to derive the equation. Now, before we do that, I do want to point out two important facts about an ideal amplifier, which is this one, and most you're going to just assume are ideal, meaning that they have an infinite gain. And so fact number one is that the voltage at the non-inverting input is equal to the voltage at the inverting input. And so what that means is there's a virtual short circuit right here between these 2 points. And so whatever voltage is here automatically shows up here. Since this is connected to ground, the voltage there is 0. Therefore, that voltage by default is also 0. So we know that the voltage at the inverting input is 0. The second assumption that we use for an ideal amplifier is that the current into the inputs is always 0. So the current into here and the current into there both of these currents into here are 0. And that's going to be, and I wrote amps here, right? And this is going to be really important. So let's start our analysis. And so what we're ultimately trying to do is finding out gain, which is defined as the ratio of output to input. So the voltage, the output voltage, divided by the input voltage, that's the gain. It's going to be a value that's going to describe how much your input voltage was multiplied or increased from the input to the output. And so here's how we're going to do this. We know, since there's a voltage, that there is a current. Let me use a different color here. I'll use blue, yeah. We know that there is a current, let's call it I1, since it's going through resistor 1. And we know that this current goes through this resistor and goes here, I1, right? Now, from circuit analysis, we know that the voltage drop across the resistor is going to be the difference between these voltages. So it's going to be voltage here minus voltage here, and then divided by that resistance. And this kind of comes from Ohm's law, right? V equals IR. But let's do this, right? The voltage here is VI, right? Minus the voltage here, which is the same as the voltage here, and we knew it was 0. And then divided by R1 is equal to this current. Now notice, right, if you multiply by R1 on both sides, that's I1 R1 is equal to voltage. That's like V equals IR. This is Ohm's law. This comes from Ohm's law, right? So we have this, right? VI minus 0 is just VI. So input voltage over R1 is equal to I1. Okay, that's a fun fact there. And now what we do know is, since that this current flows here, this I1 current, we know that the current in here is 0 based on our initial assumption. Therefore, the current has to flow here. Let's call this I2. I'll draw it here too. I2, right? We could even emphasize that it flows here. Once again, to find I2, we can do voltage here. And guess what that's going to be? The same as here, right? It's going to be 0. So, which is 0 minus the voltage here, which is the voltage here. That's the same here. That's VO, the output, divided by R2 is equal to I2, the current. Once again, voltage here minus voltage here divided by the resistance is equal to the current that flows through the resistance. 0 minus VO is negative VO over R2 is equal to I2. Now, here's the thing, right? The current that flows here is the current that flows here. Therefore, I2 is equal to I1. Hey, guess what? I2, I1, that means this is equal to this. This is equal to that. And so if we do that, right, if we say that I1, VI over R1, is equal to that, negative VO over R2, we have an algebraic equation here. And so what we could do is multiply by R2 on both sides, right? And so that gets us here. We have R2 over R1, and then we have a VI is equal to negative VO. And finally, well, not finally, but we can divide by the VI. Divide by VI on both sides. And so now we have R2 over R1 is equal to negative VO over VI. And of course we can get rid of the negative by dividing by negative 1 on both sides. So finally we have negative R2 over R1 is equal to VO over VI. And this right here is the gain. What does that mean? That means that the amplifier here, or the gain of this amplifier, is determined by the ratio of the two resistors. This resistor divided by that resistor, and there's a negative in front of it, that's why it's called an inverting amplifier. As an example, if R2 is, let's say, 10 kilo ohms, R1 is 1 kilo ohm, then the gain, right, is going to be negative R2 over R1 will be 10 kilo ohms over 1 kilo ohm. The gain is going to be negative 10. What does that mean? That means if you input, let's say, 1 volt, then your output will be negative 10 volts. You input 1 volt, it's going to get amplified by 10, and it's also going to have a negative sign. So that's the inverting amplifier.